Let us have some practice problems concerning power. Number 1. How much power is produced by a desktop computer consuming 750 joules of work in 18 seconds? Let us list down the given in this problem as follows. The energy is 750 joules, while time is 18 seconds. The working equation is P is equal to E over T. We simply substitute the values as 750 joules over 18 seconds, and the power produced by the desktop computer is 41.67 or 42 watts. That is quite easy, right? Let us have a more challenging problem. A 56.7 kilogram individual climbs up the stair inside a 4-story building standing about 12.19 meters. What would be the power outage to get her to the top of the floor in 780 seconds? In this problem, it asks to calculate the power, but we cannot have it without work, right? There is no given in the problem, so we are looking for work as well here. The given in the problem are as follows: the mass of the individual, the height of the building, and time. The value of constant acceleration is also given but implied. From this, we can use the formula in getting the gravitational potential energy to get work, which is W is equal to mgh. And in getting power, it is work over time. Then, we will substitute the given values to compute for the value of work first. 56.7 kilogram times 9.8 meter per second square times 12.9 meters, which, following the operation indicated, our energy or work is 6,773.50 joules. Now, we will use this work in getting power. Let us substitute the values as 6773.50 joules over 780 seconds. And when we compute this is equal to 8.68 watts. Therefore, in conclusion, the power output required for that 56 kilogram individual to get her to the top floor of a 4-story building is equal to 8.7 watts. For this last example, I will let you do this. How fast would the 95 kilogram pony have to run to attain the same amount of energy in joules as what a 100 watt bulb uses in an hour? I will post this video and try to find the velocity of the pony and the value of work done. Okay, look at your work and check if we have the same answers. First, we list down the given in the problem as mass, power, and time. You should be careful in doing the computation. You might remember that we don't use hour as a unit of time and therefore is not a standard unit for this particular quantity. Therefore, we need to convert first hour into seconds using the dimension analysis. There are 60 minutes in 1 hour and there are 60 seconds in 1 minute, which, following the operation, we will have 3600 seconds. We will write down now the working equation. As you know, power is equal to work over time. But since we are interested to find for work, we manipulate this as W is equal to PT. In getting the velocity, we can use the formula of KE is equal to W is equal to 1/2 mv squared, which we can further manipulate as V is equal to square root of 2W over mass. Let us solve first for work. Substituting the values, W is equal to PT, where power is 100 watts and time is 3600 seconds, the answer will be 360,000 joules. Next, using our computed value of work, let us substitute these along with mass as follows. Simply typing this in your calculator, the answer will be 87.06 meter per second. We can conclude from this that the required velocity for the pony to attain the same amount of energy as 100 watt bulb is equal to 87 meters per second. That is all for this module. Again, If you have questions and clarifications, do not hesitate to message me in our Blackboard course message or send me a message in Teams. This is Gilmar De Castro, and see you in the next video.